Further ado, introduce you to Nigel Hamilton. Thanks.
Hello everybody. Tonight I'm talking about the joy of Perl Six. So joy and Perl in the same sentence there. So I don't know if some of you have programmed Perl before. Anybody? Yeah, okay, cool, good. Okay, so I'm a lean software developer. I've been doing startups and helping other startups and established businesses for about 20 years. And Perl has been the tool of choice for that. So I like Perl. I've got a confession to make. For about 10 years, I've been lurking in the Perl Six IRC development channel, just watching what's going on. Which is quite embarrassing to have to say that for 10 years, every day popping in there and having a look at what's happening. But actually, it's been really exciting to see the various technical challenges that have come up, the design changes, the coding, the implementation, and the twists and turns that the development's taken. Perl 6 is an extremely ambitious language, and so the development of it had to match the ambition of the language. So, well, the joy of six. Well, I don't want this to be confused with the joy of sex, that manual. But there is some similarities between the advice in this book and what happened in the Perl 6 development process. First thing, playful experimentation was encouraged. Fumbling around in the dark, encouraged. Interesting discoveries were made during that fumbling process. Moaning. Normally, if more moaning happens, that's a sign that things are going well. And there was tons of moaning, so things did well. But what's happening this Christmas is that actually it's this Christmas. The running joke was Perl will be delivered this Christmas. Perl will be delivered at Christmas, but they never said which Christmas. But now, after 15 years, they've actually said it's this Christmas. So there's a lot of joy about that. But after Christmas Day and all the presents have been opened, what will be the enduring joy of six? And that's actually what I'm here to talk about tonight. And it's actually got something to do with what's happening with Federer here on the screen. What do you think is his state of mind there? Any ideas? So I think he's in a state of flow. Basically, his ability is matching the challenge. And literally, he's having problems coming down at him at 100 miles an hour. So as coders, we've got certain tools that we apply to problems that come into our problem space. And this is Federer in his problem space, in flow, dealing with it, sending back solutions across the net. So, as far as a programming language goes, I'd like it to get me into this state of mind, because this is a really productive state. You're flowing, you're being really productive, time is flying. It's a good state of mind to be in. It turns out that actually, and this is a graph that describes that relationship, basically, if your ability matches the challenge, then you're more likely to get into the state of flow. And games development companies love that state. That's what they want you to get into as a player. And we've all probably played games where actually the challenge hasn't been very high and it's actually been pretty boring because our ability matches it. Equally, the challenge may be too high and actually we just started off with a game and it's like, oh, this game's a bit hard. I might go and do something else. Ideally, you want to be matching, leveling the challenge to your ability. So this is Audrey Tang. She's a Taiwanese hacker, and she came into the Perl 6 channel around about 2005. And by this stage, Larry Wall had described, he's the language designer for Perl 6, Larry Wool had described basically what he wanted for the language. And it was just sitting there, waiting for someone to take up the challenge of implementing it. And Audrey thought it would be fun to do it in Haskell, because she was learning Haskell, and why not implement Perl 6 in Haskell for fun. So that tells you the sort of hacker that Audrey is. She's an excellent hacker. And she basically introduced this idea of let's optimize the whole development process for fun. Let's try and get people into flow who come along to hack on this. And she did this by saying, freely giving out commit bits. Anybody can come and can contribute. Forgiveness is greater than permission. So in other words, if you make a mess, no problem, we'll forgive you. You don't need our permission. Go for it. So it was a very open environment, encouraging environment. And it basically asked people to come in and pick their challenge, given their ability, and find their spot on the curve to make a contribution. And her spot was Haskell and, implementing a lot of the language. So, and the committers came. So here are the top 30 committers over the last 15 years. And there's more than that, but this is just the top 30. And the different projects that go into Perl 6, there's lots of sort of sub-projects. Some projects ended up being a dead end, but the learning that came from the project rolled on into the next one. So it was an iterative process. Audrey's version also came to an end, but the test suite that she created became part of the specification of Perl 6. So anything can be Perl 6 provided it passes the test suite. And there's over 50,000 tests there at the moment. So if you feel like writing your own version of Perl 6, there's a test suite for you, you can go for it. We had karma bots inside the IRC channel, giving karma points for every time someone made a commit. And this just marked progress. And this was essential for having people feel flow. Outside of this echo chamber, everyone's saying, Perl 6 isn't going to happen, Perl 6 is a dead end. But internally, people could see the progress being made. And the karma points that were accruing was just one measure that people could feel the progress. And this is Jonathan Worthington. He is the committer with the most commits in the repo, and I think he probably deserves special mention here. And flow is really about learning. As you move up that curve, you're actually getting more ability, looking for more challenge. And you can see in his commit graph, so I'll be back here, you can almost see his flow as he gets more and more ability across different repos. He constructed more VM, the virtual machine, NQP, not quite Perl, the Perl 6 sub-language, which bootstrapped the language, and then Rakudo, or Perl 6, the full language. And he's contributed to lots of other repos. All this comes together to make Perl 6. And then finally, the other part of the community, the culture of Perl 6, this is the logo. It's Camellia. That's her name. It's got camel in it. Excuse me. You might remember that Perl's old mascot was kind of a hairy camel. Does anyone remember that? A camel book? So this is a kind of a slight reference to the camel, but unlike a camel, the butterfly doesn't spit and doesn't smell, and so that's a change in culture for Perl 6 as well. So it's a positive culture, it's a friendly culture, and it's about making progress and helping people find that flow. It also worked really well in that it was a bit of a troll detector. People would come into the channel and start saying, oh, the logo is crap, what kind of language is this with a logo like that? And so the troll, it played a really good role as a troll detector. Okay, so that was the implementation of the language, and that's the idea of flow being in the DNA of the language, in the actual kind of community and the ideas behind it. The design is the responsibility of Larry Wall, a cunning linguist. So he's not a typical computer scientist. He approaches the problem of language design from a linguistic point of view. So he's thinking about the human being first and the computer second. And I think that's an important aspect of how Perl 6 has come together. And I want to share some of the ideas. Designing a computer language is really difficult because you've got two architectures. You've got a wetware architecture and then a hardware one, and all the smartphones in between. This architecture, unfortunately, isn't going to change. It's limited. Moore's law doesn't apply to the 7 plus or minus 2 things that our short-term memory can handle. So unless they invent some way of, I don't know, injecting more brain power, that is always going to be a constraint. There'll be a limit there. So the design of computer language needs to understand the short-term memory buffer of the wetware. And then, because this will expand, change, grow, no problem, it's this that's the constraint. So that means that if you're a programmer and you want to do your job, solve a problem with Perl 6, what you need to have is actually as much free memory space as possible to devote to the problem. Ideally, you want the language to get out of the way so that you can just think about the problem and express your solution to it. Which means then that Perl 6 has got to try and be as cognitively comfortable as possible to give you as much spare slots as possible so that you can actually focus on your problem. Because the computer language, there are 3 audiences really to your program when you type your program out. There's yourself next week, who's got to work out, oh, what was I doing there? Oh, God, what was this program on about? There's your team at stand-up. There's the antisocial member of the team who, even though he's been asked not to bring his club to the stand-up, for some reason he keeps bringing it. So there's these different audiences. Lastly, there's the computer itself. So you may not be programming in Perl, but you may have encountered one of these, a Perl-compatible regular expression. And this has been one of the aspects of Perl which a lot of other languages have sort of cargo culted. They've taken the whole thing and slotted it into their language. And in a way, I feel sorry for people writing in other languages because they're coding away in their language and then suddenly, ka-chum, they're inside this thing. Perl, a PCRE, a Perl-compatible regular expression. And even this, does anyone know what this regular expression is matching or trying to match?
Lots of 3-digit numbers followed by a number which is between 1 and 3 digits.
Yes. So it's a version 4 IP address. Yeah. And that's quite an expression, isn't it? And that will stop most people in their tracks. I have to go and read that again, and that's a bit of a flow stopper. So something like that is a challenge because you're thinking, well, I know what an IP address looks like. Why can't I just tell the computer what an IP address looks like? And the best way for us to do that at the moment is to come up with this regular expression, which is a kind of a pattern, a halfway house between what the computer thinks it should be and what humans think it should be. The downside of this regular expression, though, is that it's not cognitively comfortable for the other members in your team, and it's not really comfortable even for you. You have to come back there and just look at that and read it again. So Perl 6 is looking to improve on this. And it's tricky because, of course, Perl comes with a lot of history. So we don't want to forget all that stuff, all those great regular expressions that have been written, but at the same time want to move forward. And so here's some Perl 6. To match this string, we smart match using Perl 5, and here's an old style Perl 5 regular expression. Here is a new style one. Match, ignoring case, Perl followed by a space, and this class of characters. So there's a couple of things to note there. The modifiers are at the front. In Perl 5, in the Perl 5 version of this regex, the modifiers would be at the end. So cognitively, you would read the regex, you get to the end and go, oh, you have to go back and read it again. So just small little changes like this are part of the things that have come together in Perl 6 to just make it as sort of less taxing as possible. So modifiers at the front. Yeah. And so here's the regex for the IP. Now, can Perl 6 improve upon that? Computer's happy with that, by the way. Computer will read that all day, no problem. But it's the humans that we're worried about. Here is the Perl 6 version of this regex. Match digits 1 to 3 times. Sorry, match 1 to 3 digits and match all of that group 4 times, modulated by a dot. So in other words, four digits with a dot in between. That's a new style regex. But that's still pretty hard to process. So we want something even easier than that. So we have this new idea of regular expression rules, where you can effectively decompose a regex into tokens, just as you might take a subroutine and pull out subroutines out of it. Likewise, with a complicated regex, you pull out sub-regexes. So here we can declaratively say an IP address is actually digits, where the digits are 1 to 3, and that they're less than 256. This is actually a tighter description of what we're looking for. And that then becomes like a mini grammar, which you can then say, which you can then apply against the IP address to match it. And this then becomes much more readable to the programmer. Oh, right, okay, I'm matching the IP address rule pattern. Now, what is the IP address pattern? Oh, it's a group of digits, where digits are this. And you can see it kind of decomposes. So then ideally, actually what you want to do is then reuse, because actually a version for IP address, you don't want to be cutting and pasting that regex code into all your different places in your code base where you might want to use that. Ideally you want to reuse it. And this is where grammars come in handy. You can effectively declare a mini grammar for anything, and Perl 6 has a grammar for itself, but there are grammars for other languages and all sorts. So this is a very simple grammar. But it means that you can then reuse it throughout your code. And so here is an example of combing the logs for IP addresses. So this will use the grammar and then comb through the logs, pulling out the IPs, and then that'll give you a list of the IPs in your logs. Now, of course, there's IP version 6, much longer IP addresses with a different format, and we could add that to this grammar. So then it could be a generic IP address grammar, and there could be a version 4 and a version 6 within the grammar. And on Rosetta Code, there's an example of this type of grammar that covers both. Now, what is Rosetta Code? Rosetta Code is this fantastic language site for polyglot, whatever it is, where basically there's all these different problems and you've got different languages looking to solve those same problems. And so side by side you can see how different languages have solved the problem. And this is actually where Larry Wall has been having fun. So during the Perl 6 development process, he wasn't doing the implementation of Perl 6. He was playing in Rosetta code with different answers to these different problems. And some people have, in the Perl community, say, well, why is Larry off doing that? He should be there implementing it. But actually, I think that is the best place for a language designer to have been. He spent years on Rosetta code looking at Perl 6 solutions, looking at all the other languages and borrowing ideas, taking different influences and things from all sorts of different languages. And Perl 6 has taken in ideas from lots of languages. So it's not kind of a language which has come from an ivory tower which sort of has been dropped down. It's become part of that process of learning that Larry Wall did. And when you look on Rosetta code and you can see all the different types of solutions, you can see the choices that different language designers have made. And there's so many different kind of so many different dimensions that a language designer can kind of change how the language functional versus object-oriented versus, all sorts. There's two particular dimensions that I want to talk about that Larry Wall has really focused on in Perl 6, which is whip-uppitude and expressivity. What is that? Well, what's whip-uppitude? Whip-uppitude is the ability for you to go into a problem space and quickly get something working in that problem space, to whip it up quickly. But not just that, for it to mature with your knowledge of the problem space and how the problem space develops. So here, for example, we've got the problem, get your program to say hello world. So in Java, this is actually the learning curve for hello world in Java is a bit of a leap. You've got to understand static, void, main, you need to know that signature definition. I used to teach Java at university and students would ask, well, if I'm printing out hello world, why do I need to take parameters in? And that's a tricky question to answer, and it's a fair question. The subroutine, the sub is trying to print hello world, why does it need parameters? So this is hello world in Perl 6. And everything is an object, so you can also call say on a string, and it will print to standard out. So let's say, for example, you wanted to write a deployment script. You wanted to deploy to a node in the cluster. So you could do something like this. Declare a sub. It takes a node name, and we'll just put a stub in here for the moment, deploying to this node. Well, Perl 6 will automatically, given the main method there, will automatically come up with a help command line option for that. And so then here's the beginning of that command. So you can see you're already getting that sort of boost. Right, okay, my command's coming together. So then your boss comes along and says, actually, we need to deploy to a specific machine. I've got the IP address. I don't have the name of the node. So you go, oh, okay, no problem. I'm going to add another method, main, and here we have multi-methods. And this is new for Perl 6. So Perl didn't have multi-methods. So I'm personally really happy about that. It's taken a long time just to get that feature. So I'm so relieved that has finally come around. But what's happening here is we now have a kind of a type constraint on the node IP where, and we're making an assertion that the node IP needs to match the IP address grammar. Oh, sorry, there's a bug there on my slide. There needs to be a closing bracket there. And that will. So then when you call deploy with an IP address, it'll do the pattern match against that grammar that we created, and it's going to call this version rather than this one. So the method dispatcher will pick the right one based on the signature of the sub. And so you can see that as this deployment script grows, Perl 6 is sort of facilitating that growth, and you can imagine more things coming along, more methods. Okay, so that's whip uppitude, and now the other aspect is expressivity. So this is an old school Perl 5 program for factorial. So factorial is the sum of all the products of a number. So 5 times 4 times 3 times 2 times 1 will give you the factorial for 5. And here we've got an iterative version of this function. But it could equally have been a recursive one or something. So how does that look in Perl 6? Well, we could have gone for an iterative, we could have gone for a recursive version, we could have gone for a declarative version, but actually here is a sort of an expressive one, actually that just expresses what it is to be a factorial. And we've actually borrowed the mathematical character for factorial, exclamation mark, and introduced that into the grammar of Perl 6. So introduce that into the actual lexical scope that this part of the program is executing in. And we say, right, well, make a new postfix operator going from 1 to the parameter that gets passed in, we call it n, and what we're going to do is multiply all of the elements from 1 to n. And then what this will do is it'll add this operator, and then you can say print factorial 5, and it will just print, it will then just apply that. So what's going on here? This multiplication operator is being actually acted upon by this operator, which is a circumfix reduction operator on the list. And it's saying, as the elements come through here, multiply each element. So it's like a meta operator. It's an operator on the operator, which is what that is. So there's lots of power here, so I'm only giving a very cut down version of this, and here's just a some simple meta operators, but there are a lot of other meta operators that can come up. So we've got 1 to 3, a list, and this here will take the addition of those, the sum basically of the numbers. This will find the maximum number of the range, the minimum. This tilde will concatenate. So strings, the concatenation operator in strings is the tilde, and the mnemonic there is like a string sewing together other strings. So it becomes easy to remember. It also means you don't have to then overload it. So if you, for example, had a plus as being the concatenation operator, you then don't have to then cast operands into the right thing before it makes it simpler. And here we have greater than. This will pull out the highest one, the lowest one, and then this will pull out the reverse. Sorry, if we reverse that, then this will be true, and then that is false. Okay, so meta operators, here's another one. This is a cross product. So what we've got here is all the suits, the ranks of cards, and then we'll just use the concatenation operator and we'll say, actually, do a Cartesian product, match all of the suits against all of the ranks, which will effectively make a deck of cards, and then pick 5 out of the deck, and that makes a hand. Okay, so your boss comes along and says, I need to know all the Fridays of the month for this year, the last Fridays of the month. So if you're a lean programmer, you get your highlighter out and you actually highlight the calendar, give it back to your boss. Then he says, but I want it for any year in the last 20. It's at that point then, okay, you get your keyboard out and start thinking about a program. Here's what that program would look like in Python. Unfortunately, I couldn't fit it all on the screen. There's a bit more of it down here. So that goes through the calendar, trying to find the last Friday of the month. So this example comes from Rosetta Code. So you can go and check it out there. So what would that look like in Perl 6? Well, here's 7 lines of code, and this is the main subroutine I showed earlier. And it's saying, right, got our usage here. Show us the last Friday for a given year. It's an int. And then it will then work out the last Friday. How? By defaulting either to this year, or if a parameter's been passed in, it'll default to whatever the year has been passed in. And then iterating through all the days of the year. If it happens to be the 5th day of the week, then that's a Friday. And so we'll add that into this array. And then at the end of it all, the last one that we see will be the last Friday. And then that will say the list of last Fridays. So I hope you can see that this is sort of an expressive and a very sort of short way of solving that problem. In other languages, you've got much more sort of verbosity as you're going through the structure. Okay, so that's just a very small couple of examples of whip-uppitude and expressivity in Perl 6. There's lots more on Rosetta Code, and I invite you to go and have a look at that. Look at your favourite language, look at how Perl 6 does it, and just see if there's any difference there. And most of all, I hope that you take the time to discover the joy of Perl 6. It's coming out this Christmas, so something to download on Christmas Day and play with on Boxing Day. But I hope that you use it for the enduring thing I was talking about, the enduring joy of 6, which is to find flow for you and your team. That's it. Any questions?
You know, on the graph that you've shown about, I've already forgotten what the 2 axes are, but there was a yellow bar and there's like the kind of curvy wave going through it. I was wondering what that actually referred to and what it had to do with it.
Yeah, that I'll just pull that up. That is that's where things get stressy, and you move out of flow, and you basically you go out of flow. So
what's the difference between being in that yellow region and being in the red region?
Maybe there's a chance for you to come back.
Slightly better.
When you're in the red zone, you're in the red zone,
Right.
and yeah.
And the wave is there is just a part of the room. It wasn't clear what the wave really meant.
Yeah, okay, yeah. To be honest, I borrowed this graphic and the wave was on there. So,
Okay,
yeah,
fair enough.
yeah. But it is a precarious state of mind to be in, and it only takes your manager to, tap you on the shoulder and, I've got something really important for you to do, and it's like,
Yeah, I wondered if it meant that's kind of where people end up being.
yeah,
Between the two.
yeah.
So, who would be the sort of main, or what program would be the main sort of competition for Perl Six, or the closest kind of rival for your criteria?
Oh yeah, well actually I'm open to suggestions actually. I've spent quite a lot of time in the Perl Six channel, but that's what I'm looking for. I'm looking for a tool that gets you into that state and keeps you there, and gives you maximum sort of expressivity, maximum sort of whip attitudes. You can just solve the problem, move on. Because I mean I've worked in a lot of startups, and it's like, you know, there's the stack of cash which is burning under the CEO's desk, and you know he or she just wants a result. So, you know, at that point you just want a tool that will do it for you.
So isn't that down to what the coders are used to?
Yeah, yeah. So, yeah, it does come down to that.
I'm interested in the relationship between Perl 6 and Perl 5. Can Perl 6 run Perl 5? Will you need 2 Perls? If Perl 5 people sort of say we're not moving to Perl 6, what's the story?
Yeah. To be honest, there's been a bit of frustration between Perl 5 camp, Perl 6 camp, etc. And there'll be some people that don't make that jump from Perl 5 to Perl 6, but there'll be others that will see how good it is and they'll just be compelled to jump. But Perl 6 is a departure from Perl 5. Larry Ward just said, actually, we're going to completely redo this. And so just cut clean for that. But absolutely learnt from the lessons of Perl 5, asked the community for how it could be improved, assimilated all this feedback, and then embarked on the next design.
Can Perl 6 run Perl 5 at all, or is it?
There's an inline Perl 5 module which will basically inline a Perl 5 module into the Perl 6 environment. So it is possible. Yeah.
If you have a code base of Perl 5 though, can you run Perl 6 and Perl 5, or do you have to upgrade all your Perl 5 to Perl 6 before you can run Perl 6 on the machine? Or can you run both as well?
Yeah, there is actually, on the Perl 5 side, there's an inline Perl 6 module. So you can inline Perl 6 into Perl 5. And then there's this weird thing that happens when you can inline between both, and then, yeah, and then your brain really does explode. Yeah.
So I'm going to say that if it's launching this Christmas, what comes afterwards for Perl 6? What's the future look like for it?
Well, joy. Joy, we'll just be sharing the joy.
Have they got plans to, is there more features that need adding to it?
Oh yeah, that's a fair question, yes. So there's quite an ambitious macro framework, and that hasn't been implemented yet. So they're still actually thinking that through, what's the best way to do that.
Perl 5, which I enjoy, you can write a very simple sort of almost like structured program, or you can do super cool, super compact. There's more than one way to do it. It looks like they've taken that up a level again. You started crossing out simple solutions and had something that was really concise, but isn't there a massive amount of language that has to be behind that, and kind of grammar rules, and can 2 Perl 6 programmers understand the same piece of code, or will they just choose their own way to do it? Is it like for individuals with their own programs?
That is a really fair question. And I'd like to think that actually Perl 6 is driving towards that kind of harmonious, we're going to help each other flow. We're not going to put flow stoppers in front of each other. We're actually going to, help each other solve this problem here. And so communicating to each other first and communicating to the computer lastly. But any computer language can be sort of badly coded, and you can...
I'm not talking about bad, I'm talking about there's more than one way to do it. You can write extremely simple, verbose Perl 5.
Yeah.
You can write extremely compact code that you have to be a bit of a guru to understand, or not a sort of someone that's a traveller to the language, if you like.
Yeah, I hear what you're saying, yeah. I suppose if Larry Wall was here, he might say that actually he would just want people to have as much power as possible, but with great power comes great responsibility, and that you're supposed to code in a way that's sort of socially friendly to other people who have to use that code. Because we could all write really compact, like golfed code that's almost impenetrable, but don't do that. I think that's the thing. It's probably a cultural thing. There's nothing in the language that would enforce you to do that. I suppose he wants it to be a bit like a human language, in that he wants people to have the freedom to express themselves in whatever way that is. And in Perl's history, there's been actually like Perl poetry and all sorts that have come out, which is weird to think of, isn't it? That you write poetry with your program, but yeah, and certainly lots of freedom to do that in Perl 6. Commas, for example, can be part of identifiers. So you could have, Shane's disk, comma, in there. Things like this.
Do you think there's a trade-off in performance for the expressivity of the language?
That is a good question. So Perl 6 is not going to be fast on Christmas Day, and this is going to be one of the things where the people who want to detract from it will benchmark it against different languages, and it'll be, look, Perl 6 is slow. There we go. We don't have to worry about it, But the point of it is that it's actually been focused on the language aspect, the human aspect. The speed will come.
I asked that because Ruby, I wrote more Ruby than anything, and that's very expressive, but there's a bit of a bad rap when it comes to performance.
Yeah. So there's more work to be done on the performance side, but the architecture is in place for it too. There's a just-in-time compiler, which is just in its initial stages.
I wonder if we'll end up with American Perl 6 and British Perl 6.
Definitely, yeah.
The question I was going to ask, I'm sorry if you mentioned it earlier and I missed it, but what's it written in?
What's Perl written in? What's Perl 6 written in? It's written in a combination of Perl 6 and what's called Not Quite Perl, which is sort of a bootstrapping sub-dialect of Perl 6. So, yeah, there's a core part of it, which is in Not Quite Perl 6, and then quite a large chunk which is in Perl 6. So it's not written in C, which is good, because that was one of the problems with Perl, and that the core engine was written in C, and the code had become a little bit hard to deal with.
I was going to ask, sort of to pick up on the point he made, is there a significant performance difference between using a really concisely written version of something and using possibly a more verbose way of expressing it? Or do they compile to roughly the same sort of speed?
Yes, I think it's. I mean, they really haven't looked too much into the performance, and it's a bit too early to say. One dialect might be faster or slower than the other. Okay. All right.